Let's take a look at a couple more examples of this fundamental counting principle, or FCP for short, in action here. So continuing sort of the let's look back at Professor Carroll's memories. So you'll recall I'd gotten paid, I was able to buy new clothes, and then it turned out that now having finally finished grad school, my wife and I were looking forward to having a little more disposable income than the flush nature of life as a mathematics graduate student. So anyway, so my wife was looking forward to decorating the living room, without having necessarily, without being bound by the extreme budget constraints of life married to a grad student. So as she was looking around, here's what she's ended up categorizing things as far as the living room decor. She wants to pick out a paint color. Okay, she needs to pick out a sofa, coffee table. I always sort of imagine this like the Better Homes and Gardens, like the one feature wall that you like end up seeing in the picture. So she's picking out a paint color, a sofa, a coffee table, and then of course we need some piece of artwork behind that sofa that's against the wall, right? So yeah, that's. Does this sound decorator like? If not, I'm sorry, I'm really not a decorator. So anyway, going through the options that she has available to her, we have 11 different choices of paint that she's narrowed down to. You don't want to know about how many swatches there were lying around our house at that point. So she's got it nailed down to 4 different types of sofa, 3 styles of coffee table, so maybe one with like a glass top or like a rounded thing, or you get the idea. And then when it came to art, she got it knocked down to 6 possibilities. Okay, so now, like we've seen in our previous examples, the fundamental counting principle says if we're picking out one of each of these things, we can just kind of multiply our way down the line. So I put in my little, multiplication dots, and if I work out the arithmetic here, again, we've kind of moved beyond the ability I have to do this sort of stuff in my head. So I've got, a little calculator, here. When I punched all of this stuff in, I ended up getting 792 different ways that our living room could have been decorated. So, there were a lot of options available. Let's just, put it that way. All right. So that's what my wife was wanting to do with these brand new faculty paychecks. I, on the other hand, was more interested in setting up my home theater system. So, so when I was setting stuff up, I am, so like I guess the side opposite the camera where you have the fancy accent wall thing, and then all of my crap was across the room. But anyway, so here's what I was looking at. So I need to pick out a nice big screen TV. It's actually not that big a screen. We've had this TV for a while, and it's actually not that big because we didn't want to have to move it from one place to another. So we had, as we said, we wanted to pick out a Blu-ray player for now that we got this big swanky TV. Let's watch some, high quality, movie stuff on it. And I wanted to get some sort of, like sound bar kind of thing to, enable this stuff. All right, and as I've let the cat out of the bag on this previously, I really like playing video games. So I also was trying to figure out, I had 3 video game systems at the time. I didn't have to go out and buy those. I'd scrimped and saved even in grad school, so I had decent video game systems. But I was trying to figure out, am I going to plug my video game systems into this thing? So what I usually ask people to do at this point is I've started kind of laying stuff out here. Press pause, see what you can come up with based on what I've laid out as far as the as far as these categories are concerned, and then we'll talk about the answer. Okay, so you had some time to pause. Generally speaking, what happens is I used to do this like as a game show thing in class, where I'd call different people up to the board, after they thought they had an answer, and then like on the count of 3, they'd write up their numbers. And it's not often that I actually have somebody come up with the result that I'm expecting to see, and we'll talk through why at this point. So this is sort of the way people usually have stuff bracketed. Anyway, so as far as the TV is concerned, I told we had 7 possibilities there. So if you want to look at the PowerPoint slides for this that I've got posted in Moodle, it lists this stuff out, just not quite in the same structure. So, and then I had 5 Blu-ray players and 6, surround sound deals. So This part everybody's pretty much on board with. 7 times 5 times 6, they come up with, I think it ends up giving you 210. So that part they're all fine with. It's how to deal with this guy in the back that ends up giving people kind of, a hard time with this. So what will often end up happening is they say, well, okay, well, he said he's got 3 video game systems. Chunk, they'll write the number 3 in there. And then they multiply 210 by 3, they get 630. That's not what I'm looking for. Somebody else will then end up looking at it and saying, well, he said, does he want to connect them or not? So that's like a yes-no question, right? So there's really 2 choices right there. So they'll have a 2, then they write 420. So yeah, go ahead, laugh. After that, then I end up saying, no, that's not what I'm looking for either. It's actually a little bit trickier than that, and this is actually one of like the biggest wrinkles that ends up coming up out of this. This is technically not just one choice, it's actually 3 separate choices. The way I usually describe this is, have you ever looked at the back of a television these days? There's like a dozen little ports and sockets on the back. I wasn't restricted to plugging in only one video game system. I'm no longer having to do those awkward like splitter box, shenanigans to figure out how to get everything connected. So I'm not constantly unplugging stuff if I want to switch from my PlayStation to my Xbox or something. So as it turns out, it's actually 3 separate choices. Like one of these game systems was a Nintendo Wii. If I'd blown up Nintendo Wii quality images on like a big fancy HD TV screen, it would have looked pretty terrible. So maybe I don't want to plug in all 3. Maybe I only want to plug in the ones that are capable of actually like higher quality graphics or something. So that's kind of a false choice there. So what ends up happening is I actually have 3 separate decisions to make here. 1 yes/no question for each system. So it turns out each one of those 3 guys actually has 3 possibilities. So yeah, technically this dot is carrying over to there, but my board is short, so I don't have room to fill it all in. So when you work this out, 7 times 5 times 6 times 3 copies of 2, or just 8 if you prefer. So I actually had over 1,600, 1,680 to be precise, different ways I could have decided to configure this kind of home theater thing. So that's about the trickiest kind of thing that ends up coming up as far as how you end up having to address these questions. So be careful if multiple options end up getting lumped together because English is weird as a language sometimes. All right, so now I want to take a kind of a twist on this counting principle thing. So bear with me just a second. So all of the things that we've been looking at so far, with maybe one exception, the way we've been looking at it, the decisions we're making, the choices, they're all more or less independent of each other. Like, in my initial thing, whichever shirt I chose didn't eliminate certain pairs of pants from being selected, or the type of TV I picked didn't alter which Blu-rays I could plug into it, or what have you. I do want to take a look at some situations, though, where we end up losing options as we make choices at the beginning, and things that impacts what comes further down the line. So if you look in the PowerPoint slides for this, there's like a little, there's one slide that just says, do you know this man, with a picture of a man. And I usually like to ask, who knows who he is? For what it's worth, almost nobody has ever known. I think I've had one student in like 7 or 8 years of using that PowerPoint slide. So the picture, as it turns out, is of the actor Cary Grant. If you don't know him, it's okay. He died before most of us were born, so that's a thing. I was like 7, I think, when he died, and he'd retired from acting years before that. So anyway, so I really like Cary Grant movies. Like, there's a lot of Cary Grant DVDs. I used to bring them to class as like a visual aid. So it's really, I'm trying not to go off on a rabbit trail here. I'm short on time. But anyway, I like Cary Grant, and I like to bring this up as an example of, like on his birthday or something like that, we're going to do a movie marathon of 6 of his films, to commemorate his life and work, that kind of thing. And I want to know how many different ways we could arrange this movie marathon. All right, so we can attack this using the same old fundamental counting principle. So we'll have 6 slots. I'm hoping I don't run out of room here. I didn't. Okay, so I've got 6 slots to work with. And you can sort of make your way down through this the same way we've seen previously. Well, we have 6 ways we can pick out the first movie. Now, you might end up saying at this point, well, don't you just have 6 for all 6 slots? I mean, I guess, but it's not a very exciting marathon if we just show one movie over and over again, I mean, I like North by Northwest as much as the next person, but I'm not going to want to watch it 6 times in a row. So generally speaking, whatever we've shown here, we're probably not going to want to show again, right? So that means we have one fewer option at this point. So we're down to 5 choices for movie 2. Same idea. We're not going to repeat either of the first 2. We've got plenty of good cinema to show, so we go from 6 to 5 to 4. Hopefully you get the idea at this stage. So yeah, we make our way down to the end. We have 6, 5, 4, 3, 2, 1. And the counting principle, still in effect, says we multiply all of those guys together. And if you work out the arithmetic there, so we have 720 different ways we could show off our movie marathon. So that's, as you say, that's our answer for this. And it turns out this notion of losing one option from our available slate each step of the way, it comes up an awful lot in these counting, combinatorial type problems. It comes up often enough that it gets its own name. All right, so we're going to end up talking about what we call the factorial of a number. So that exclamation point is like math symbols for a factorial. It's not, I'm just really excited about n. So for a positive integer n, 3, 7, 29, you get the idea. We calculate its factorial by sort of starting from the number in question and then multiplying down by all of the positive integers less than that until we end up getting to 1 at the end. So for what it's worth, I will point out, in case it ends up coming up, we do actually define the factorial of 0 to be just 1. So, that doesn't matter much. It just makes some other formulas cleaner. So you can work that out. The catch is, again, I said it comes up a lot, and it's not something that, for a really big number, you don't want to keep writing down 29 times 28 times 27. It's really easy to overlook something, right? So as it turns out, most calculators that I would expect you to be using in this course have sort of a button that will do a factorial for you. So I've got my TI-83 right here. So you'll see I've already got the 6 from that last example written in. So to get to the factorial, well, shoot. Managed to mash a random button there. So we're going to want to hit this guy here labeled math. So you hit the math key, point. It pops up a big menu of things. All right. So what we're going to be after is over here in this menu. You notice I'm trying to hold it nice and still. You got, a bunch of stuff. That 4th guy looks like an exclamation point. That's the factorial key. So move the arrows down there. I hit enter. And I get 720, which is what we came up with earlier. All right. So yeah, generally I don't expect you to work out these factorials by hand. All right. So I had one last example I want to take a look at. So I'm not really a horse racing aficionado, but it works out well for an example of this stuff in action. So imagine we've got 8 horses in a race, and we want to know how many different ways the horses could cross the finish line, assuming there aren't any ties or anything like that. So you could lay this out just like we've done before with the counting principle. 1st, 2nd, 3rd, all the way down to 8th. But since each horse is only going to be able to cross the line once, we're losing 1 horse from each choice along the way. So you could use the counting principle, but there's no reason not to just use that factorial key that I've already pointed out on your calculator. And if you do that, you should get 40,320 possible finishes of all the horses in the race. So that's an example of factorials in action. So we've done some more stuff with the counting principle. We've done some stuff with factorials. So hopefully that's got you set up for the stuff in section 2.3. We're still going to be talking about counting in the next section, but we're going to take kind of a different twist. So, hopefully that's enough of a cliffhanger for you.